In this video I'll talk about the code side of your bin indicator. You've got your bin and it lights up to simple Arduino code, but now you need to connect it to the console. A video talking just about code where I go through and read out the code and describe what it does would be really boring. So I'm going to try and do as little of that as possible, but what I will do is make sure I cover the theory, the reasons I've done things certain ways. I will show you the code, but I won't be reading it out. First of all, let's talk about the overall design of the system. The system is going to be what we call asynchronous. If you're not sure about asynchronous versus synchronous, I'll give you a good example. Consider you've ordered something online. First you have to wait for it to be delivered. You'll be waiting for somebody to come to your door and ring your bell. The delivery driver will come and ring your bell, and then he has to wait for you to come to the door. And then he gives you your parcel and leaves. Now that's synchronous. The two parties are dependent on each other. They're in sync. But it also introduces something called blocking. What that means is the delivery driver is blocked while he waits for you. To some degree, you're blocked waiting for something to be delivered. The delivery driver gets to your door, he knocks on your door. If you take 2 minutes, he has to wait 2 minutes for you to get there. So that's synchronous. You're blocking him, he may be blocking you. It's not a good situation in a system. The alternative example of asynchronous parcel delivery is Amazon lockers or some other kind of system where parcels can be stored. In that case, the delivery driver goes to the Amazon locker, he puts your parcel in it, and he's not blocked. He can just move on to his next one. You're not blocked either because you can just pick it up at your own leisure. So that's an example of things happening more or less asynchronously. Order is still important, but neither of you are really blocked. The bin could connect directly to the council website itself. It could connect to the council website, wait for the council website to load, do the work, get the information, and then change its lights based upon that. But then you're coupling your bin to the council website directly. It doesn't sound like a bad idea until you consider some of the other aspects. So for example, you don't want to overload the council website. You don't want to keep hitting it over and over again, especially when you're testing your device. You don't want to keep loading the council website. And it's not considered good practice to keep scraping websites over and over again. So what we'll do is we'll have two separate processes. So one part of the process will be connecting to the council website once a day, finding out which bin is due, and then remembering that information. And the other part of our system will check that remembered value. Because it's asynchronous, my bin can check every 30 seconds if it wants, and it's not going to connect directly to the council website. Instead, it'll use that cached value from earlier. Because we can consider there's two different processes here, that means we've decoupled the action of finding out what colour bin it is to displaying which colour bin it is. On the bin, it'll just be running Arduino code. We could have the bin connect to a website, process the HTML response, and do everything else. But then you're really doing maybe more than you should do in a piece of hardware. But a nicer approach is to have a single responsibility for different things in your system. So in our case, we'll have the bin only be responsible for displaying a colour, and we will have a separate entity, a Node Red server in our case, which will be responsible for finding out which bin is due. Node Red is a very handy server for IoT devices on your network. Node Red, it's easy to use. It's largely drag and drop, although not entirely. And it comes pre-installed in Raspbian. So if you have a Raspberry Pi with Raspbian installed, you already have Node Red. There are some tweaks you can do to make it a bit better. I will link a video in the description that shows you how to expand it slightly and also add password authorization. Here on the screen you can see Node Red. Node Red has a concept of what are called flows. Perhaps you could consider each flow as a small program. I already use Node Red for other smart home type applications, you could say. So for me, it was a no-brainer. Here's my complicated, I don't know what you would call it, smart home. Well, it links temperature sensors and monitors my solar test setup and things like that. So I already have Node Red, and I enjoyed using it. It's quite easy to use, as you'll see, and it seems a good fit for this. Okay, the first thing we'll do is we'll set up our flow in Node Red. This flow will connect to the council website and it will store the bin in a variable. We need to do something every day. We need an entry point for our flow. Flows have messages going through them, so you'll see the term message quite regularly. You don't need MQTT or any messaging setup for this example, but you can set it up if you want. So in the video I'll link to, he sets up MQTT, I think, but you don't actually need it, not for this. Okay, so we'll start with this inject. What this will actually do is it's a way to kick off our flow. So if you go into here, you can have this repeat, and we're going to have it repeat every day, 24 hours, and give it a name which tells us what it does. Okay, so you can see the little recurring arrow. Every day we're going to do something. And the thing we're going to do is we're going to get a web page. So what we're going to do there is we'll do an HTTP request. As you can see by the little globe, that's a web request. So it's going to connect to a web page and do a request. Again, double click on it to configure it. And here we have our method, which would be get for this. I'm going to keep this simple, so I'm just going to show you examples where you just get data from a web page. If you needed to, for example, put in your postcode or other information, you would be using probably post or maybe put. It depends on your council website. For mine and for this simple example, we're just going to stick to get. And here's the bin page for my area. So this is the page we want to get. So copy that. And paste it in there. And we'll give that a nice name. So every day we get the council web page. But what we've got here is we've got this big page full of stuff. And you don't want to parse this whole page because it's massive. Look at all this stuff. Yeah, you don't want that. So what you want to do is you only want, here I'm going to go for this one, this area. And under this area there's a bin and some text. So the only bit we're interested in is this, really. Here there's only one bin due this week, but there could be two. What we do is we need to pull out just this piece from the page. How do we do that? If you go into inspect mode, that's Control-Shift and I, or you can go into the menu options and go to Tools, Developer Tools. And then if you click on this little arrow in a box here, that lets you select an element in the page. And what we're going to do is going to select the element we're interested in, which is just this text. And as you can see, it highlights it here. Now, in this bar underneath, this is essentially the address within the page of that. So you can see how heavily nested it is. Easiest thing to do, just copy it. So if you right click on it, you can copy selector. So now we've got the whole page, we need to pull out just that part. And what we can do is we can use a selector. Okay, HTML. This is going to let us pull something out. Again, we'll link it. And in here, you can see there's a selector. Paste it in here. We'll leave that as a message containing an array because there may be more than one. Done. So the output of that now is an array. Handy thing at this point would be to just confirm that what you think you have actually works. So let's pull a debug node on. A debug will just be a way for us to print out our result, and we'll link that up. In debug, I'm going to only view current flow. Okay, one other thing, just to make your life easier, is rather than waiting every day, while you're developing it, it'll be annoying having to wait a day to find out if it works. So if you click inject once at start, then every time you deploy it, it will load it immediately. Or run it immediately, I should say. So here you can see the selector's worked. It's pulled back our non-recyclable waste value from the web page. If that said something else, it would have said something else. We don't want to tell the bin indicator things like non-recyclable waste and have it try and figure out what color to show based on that. What we want to do is have the bin do the simplest thing, which is just you tell it what color to light up or colors, and it does it. It doesn't really think about words and doesn't have to parse strings. So what we're going to do here is we're going to do a little lookup. We're going to do a lookup table that takes in words like non-recyclable waste or paper and card and returns a color like blue or green. And this is the part where I'm not going to slowly type in some code and slowly read it out. I will just paste in, but what we need is a function node. A function node really just allows you to run any kind of code, JavaScript that you want. And you type it in here. Again, it talks in terms of messages because everything is a message as far as Node Red is concerned. Now I'll paste the code in. And I will briefly explain it. Here is just a loop. And it's just going through the length. So there may be more than one bin. There may be 2 bins or 4 bins or however many. This will cope with it. So it goes through every bin. And then on line 4 is a little bit of extra messing around I had to do with my personal council's website. They didn't always have this, but they changed it at one point and they started putting line breaks and other things in with the text. So you may not need this, but what this does is it uses a regex to replace all the line breaks it finds with just nothing. All this does is remove line breaks. It shouldn't cause a problem. You could leave it in. If you don't want it, you could just get rid of it if you don't need it. And then here's the lookup table or the mapping. It just simply checks the text and tells you what color the text is, and that's it. It replaces a string in the array that was a string of descriptive text with a color. As always, there's more than one way to do this, so if you wanted to, you could actually put the hex value or the RGB values of the colors in here, but I like the idea of it just returning text for this. And we'll give this a name. so we remember what it is in future. Convert name to color. So we know what it does. This happens once a day. Our bin will be checking this Node Red flow multiple times a day. So what we need to do is we need to cache this result. We don't want to check over and over again. We're just checking once. So we need to cache it somewhere. I'm going to put it in a global variable. That may not be appropriate for you if you have more complicated setups, but it's the easiest thing to do. And all you need for that is a function. So I'll drop another function in, link it up. And in here, we're just going to set a global variable called bin color, and that's the message payload. Global variables are generally bad, but in this case, for this example, I'm going to do the easy thing. And that, my friends, is done. Ta-da! You can deploy it, check it still works. Yep, still works. The next step is the other leg of the asynchronous part of this. And what we're going to do is we're going to make a web page so that we can see what this value is. We won't even need a bin. And to do that, we need a HTTP in one of these. So this is the entry point. The entry point here is just a trigger, a daily trigger. The entry point here is that somebody visits an address. Leave that as get. The URL could be anything you want. The example I already have in place is bins. I can't do that again since I already have it. So I'm going to call this one my bin. So you could consider this as a web page address. When somebody hits this web page address, what happens is a function is called. Let's add a function. And this function will take out the value that we previously stored in the global variable up here. Here's the code. First line, the way Node Red works is each node has to output a message. So for that, I'm just going to use a clone of the incoming message. And the new message payload will be the global variable bin color. And this little replacement at the end is just to replace any quote marks. By default, there are quote marks in there, and it's just easier to parse without the quote marks. JSON stringify really just makes a nice JSON object out of it so it looks nice. So it looks like this. Square brackets with an array of values within it. Meaningful name, and the next thing we need to do is we need to display this on the web page. Node Red has lots of different ways of displaying data. It has a templating engine built in called Mustache. So here we have our template, link it up. And we don't need this whole thing. So we don't need any other text. We'll just leave it like that. On page. That will do. And that's about it. You want to return a successful error code, really. Nice HTTP 200, meaning everything was successful. Now if I deploy this, and then I go to this new one, my bin, you can see it's outputted green. So So just to summarize, it got the information from the council webpage, it converted the text non-recyclable waste to green, stored that in a global variable, and then when you visit this webpage, my bins, it gets that same value and displays it. Pretty simple. And that's the Node Red side done. And the next step is the Arduino code to light up the bin. I've kept this fairly simple. You will probably want to extend it, but I think this is the minimum really you need. I will go through it and explain what the various things do. At the top, you've got your includes. There's a few things for the Wi-Fi setup. The NeoPixel library you need for lighting up the LEDs. HTTP client, because what we'll be doing is having the ESP8266 load the web page that we created on Node Red. So that will hit the my bins or bins page and return data. The data it returns is in JSON format, so that's why we're using the JSON library. A couple of definitions of pins and pixels. In this example, there's only two. My bin collection is only a maximum of 2 bins on a single day. You may want to change that. And here we have some constant values. So this IP address you would replace with the IP address of your Node Red server. SSID and password are for your Wi-Fi. Here I've just got some colors defined easily as variables, or as constants I should say, rather than having to do RGB values within the code. Makes it a bit easier to read the code. Here we just initialize our pixels. Okay, in the setup, we've got some setup code for the Wi-Fi. Wi-Fi mode, you don't always need this, but a bit of a pitfall with the ESP8266 people find sometimes is it actually remembers what mode you put it in. So if you've run a different sketch that put it in a certain mode, and then you don't set the mode at the start of your sketch, it'll be in the wrong mode. So maybe just keep that in. And here we start our Wi-Fi and we just wait for it to connect. You don't really need to know the IP address for this, but I've got a few debug prints here and there. Obviously, if you get stuck, add more. And we start up our NeoPixels, and in this case, I'm using the pixels as a bit of an indicator. So obviously, if it's plugged in somewhere, you don't see all these serial messages, but a dim white light on one of the pixels tells me it's got to this stage. And the rest of it is one big loop method. Obviously, try to, as your code gets bigger and more complicated, break things down into smaller methods. Here I try to combine various things just to fit it in a smaller amount of code to display. It connects to this web page. This is the one we created earlier. Obviously for this tutorial that would be my bin. Is it my bin I called it? Whatever I called it. Whatever you called it. If it fails, it will give you an error on the serial console, but it'll also light up just one pixel red, which is a way of finding out it's a problem. And then if that's okay, what it does is it does a get on the HTTP object. In short, that loads the page. The HTTP code should be 200 because that's what we returned. And here is just some parsing. I could have deleted even more to fit this on screen. I'm not going to read it all out, but basically you need a buffer, and the library allows you to parse the array, and Here's a bit more of some error handling if it failed. It returns. Otherwise, you've got your array and you're just going to really go through it. And here what we do is we just parse each entry in the array and we check what color it is. So string compare, if it's green, and it's a bit weird to read, but 0 means it matches. So here JSON char is green, so we set it to green. This last color is for repeating. Say there's only one bin, which there is in our example this week. There's only one bin. So the last color is green, and we're remembering that because we don't want only half the bin to light up if it's one color. Sorry, if it's one bin. We want the whole bin to light up. So what we do at the end is, there's only one bin, we repeat the color through the rest of them. So this means the whole bin will light up the single color. So here for this example, I'm only delaying 3 seconds. Here's where the decoupling and asynchronous nature comes into play. You definitely don't want to hit the council website every 3 seconds. If you're particularly unlucky, they may even ban your IP address for hammering them. Here it's fine because what it's hitting every 3 seconds is my own Node Red server. I don't care. I wouldn't leave it at 3 seconds. The only reason this is at 3 seconds is because when you're developing something, you want it to run pretty quickly so that you can play around with it, watch it change. Once you're happy with this, you would change it to something like every minute, every 30 seconds, or whatever. The only bit I missed was closing the HTTP connection at the end. If you don't close it, bad things happen. I can't remember what happens. Possibly memory leak. I seem to remember if you don't close it, you get kind of weird behavior. And that's it. It's all very simple. This is a simple case, but this is everything you need.